Hello, my name is Manisha Lewis Cole, and I'm a graduate student at Elizabeth City State University. I'm aspiring to receive my degree in mathematics, and I'm honored today to present to you prominent mathematician, educator, and award winning philanthropist, Dr. Marjorie Lee Browne. As I take you on a journey of her life, you will see how she has made major contributions in the field of mathematics. Let me take you back to a time that, despite the racial tensions and tragedies occurring around the time of Dr. Browne's childhood in 1949, she became the third Black female to earn her PhD in the field of mathematics. After Browne earned her PhD, another Black woman would not earn a PhD until the 1960s. And from the 1960s to the 1980s, only 16 more African American women would complete doctorate degrees in mathematics. Marjorie was born in Tennessee. She was only 2 when her mother, Mary Taylor, died and her father remarried. So she was raised by her stepmother, who was an educator. Her father's name was Lawrence Johnson Lee. He was a math wizard and he worked as a railroad postal clerk. He attended some college, I believe it was around 2 years, and that was very rare for a man in the 1900s. But he used to discuss math problems and their solutions, and he just instilled mathematics in the home. Marjorie Lee developed a talent for the subject, and her stepmom noticed she was gifted, and she encouraged Marjorie to pursue her studies seriously. Her father wanted the best education, so you'll see that she attended the Lemoyne Normal Institute. And I found a little photo. I know this is not her actual class time, but she excelled in her studies in this school, and she was also good in sports. It was noted that she won the Memphis Women's Tennis Singles Championship while she was at high school. So, upon completion of her high school, she enrolled in Howard University. We all hear of Howard. Howard is one of our predominantly major HBCUs in the United States. And she was able to attend, and we're talking in the 1930s, 1930s. She went to Howard University and she received her Bachelor of Science degree in mathematics. Bachelor of Science degree. And it wasn't easy. She had to work, she had scholarships, and she also just saved her money. And I'm pretty sure it was due to financial support of her parents. Upon completion of her BS, she furthered her education and she worked as a teacher, but also had the opportunity to enroll in the University of Michigan. Now, at the University of Michigan, she was able to complete her Bachelor's of Science degree and also continue to teach through a teaching fellow. And she went on to get her PhD in 1949. Her thesis was the studies of one parameter subgroups of certain topological and matrix groups. A mouthful, a mouthful. She initially worked with secondary school mathematics programs, and she focused especially on encouraging math educators in women like me and minorities like me. She joined North Carolina Central and she conducted research, and she was there for almost 30 years. Being one of the few people who had a PhD in math, she chaired the mathematics department for years, and became their principal investigator, coordinator, and also a lecturer. Now, to look back on Marjorie's life and look at some of her major contributions, we can go to the study of square orthogonal matrices. Now, we learned about matrices. It's just another form of linear algebra that helps us with solving the systems of equations. And as we learned about square orthogonal matrices, they are defined as Orthogonal if the product of itself and its transpose is the identity matrix 1001. And a square matrix is basically all of the columns and rows are equal as far as number. So we're going to take this 2 by 2 square matrix, calling it B. And I use some numbers like -1/2, square root of 3 over 2, square root of 3 over 2, and +1/2. And we're going to multiply it by, this should be B transpose. And we know it is transposed because the row is now the column. So B and B transpose, when we multiply them, we of course multiply row times column. We get -1/2 times -1/2 plus square root of 3/2 times the square root of 3/2. We add those together, you get -1/2 times -1/2, which gives you a +1/4. The square root of 3 times the square root of 3 gives us a positive square root of 3 over 4. 1/4 plus 3/4 would give us the 1. Now when we come over here and you multiply, you get the -1/2 times the square root of 3 over a half plus square root of 3 over 2 plus a +1/2. It's kind of hard to do that mathematics, but when you look at it, this is negative, this is positive. They're just opposites. So when you add them together, it's going to just give you 0. Again, multiplying row, column, we add them together, we get 0. Row, column, add them together, and we get 0. So therefore, B times B transpose would give us the identity matrix. Hence, matrix B is orthogonal. And it's orthogonal again because the product of itself and its transpose gave us the identity matrix. So therefore, we see that this is some of the things that Dr. Lee studied. She would also contribute the decomposition of matrix groups, the breakdown of a group into a product of factors so that any member can be written as a product of such factors. She talked about connectedness of sets. If you cannot break up a set into 2 disjoint open sets, it is connected. These are just some of the things that Dr. Lee did with her lectures and her presentations as she went on with her studies. So this wasn't the only thing. She just had a love for people and a love for learning, and she started to venture out into the computer science era. And in 1960, while she was at North Carolina Central, she wrote a grant for them to get the first computer. Now, this computer was the first computer known to a Black school. I'm sure there were other computers, but IBM gave her a $60,000 grant in order for her to receive this money. She was gifted. I mean, she would assist others. She knew how to get money. She knew how to help others, and she would select the gifted ones and assist them while they were teaching in secondary institutions. She even studied, she organized summer institutes, and there were high school teachers that she would give them opportunities to continue their education, and she wrote notes, her own notes that was used within those summer institutes. She had a wonderful love of mathematics. She received all types of degrees. One prominent degree from the North Carolina Council of Teacher of Mathematics was the W.W. Ranking Memorial Award. She served on several associations, societies, and she also had many publications in her name. As far as I know, Lee never married. She had no children. She just devoted her whole life to the subject of mathematics and her students. She worked at North Carolina Central for the remainder of her life, and around 1979, she had a heart attack and she died. But her legacy lives on. A foundation has been started in her name, scholarships, lectures, and people just, I mean, Dr. Lee is one of my heroes. And as a Black female studying in the sciences of mathematics, she has given me the determination to continue my studies and to also give back to others and find ways that I can help others and encourage young Black women to be mathematicians in the future. So I hope you enjoyed my presentation. I thank you and have a good one.